Hi everyone, you can hear me okay? See the projector okay? Great. So we are going to talk to you this morning about Estuary, our research project that's been going on for about 2 years. And we're going to switch between English and Spanish at a few moments too. I might try to do some live translation, so go easy on me. Luis and Esteban. The project has some goals and motivations that I think people will recognize, and goals and motivations that I think we've already heard Esteban speak a little bit about in his work. Taking the liberty of coming at it from a personal perspective, the image on the left is a TRS-80 color computer 2. It was a home computer that was distributed by Radio Shack in the 1980s. We had one in our home when I was a kid. And when you worked with this computer, you plugged it into the TV, you turned it on, and the very first thing that you were greeted with was a blinking programming interface. And you can start to learn things to type into it there. And at around the same time, many children, myself included, had experiences in schools with the logo environment. That's the picture you see on the right there. Because of the work of the people, the creators of logo, but also the work of many IT people, school administrators, teachers, there were logo labs in lots of schools at that time. And again, the experience of starting to program in this environment was one of sitting down in front of something that was ready to go, and you were ready to express yourself with. So going on a limb a little bit, I think that there is often a contradiction in live coding between our stated desire to be very transparent with people and invite participation. This takes the form both of the sharing of the code and also of frequently of explicit statements by live coders that we're interested in getting more people involved. Contradiction between those things and the really relatively extreme difficulty that often accompanies starting to work with, starting to install, starting to manage the software of these things. I think it's very easy for people, like many of the people in this room who are experts, to underestimate how difficult these software packages that we take for granted are to just get going in different software environments. So this was really the major motivation for this project, which was supported by the Social Sciences and Humanities Research Council of Canada, who now have supported a whole series of live coding related projects. So thank you to them. We hope that support will continue into the future. So there's a couple of more specific motivations or design criteria that went into the project. One of them was an interest in structure editing, because we're interested in making it easy for beginners in some sense. So structure editing is a way of creating programs where you can only make valid structures. Or in softer forms, you are strongly encouraged to only make valid structures. So a very common paradigm of this is block-based programming. From the live coding community, many people will know Dave Griffith's scheme bricks, an example of a block-based language. And many millions of children that are currently in school will have had experiences with the Scratch project at MIT, another block-based environment. And in our design of Estuary, block-based ideas were a starting point, but something that we ultimately departed from. We were also interested in projectional editing, which in the computer science literature sort of overlaps partially with interest in structure editing. Projectional editing is the idea that when you're making a program, maybe you can look at that algorithm from different perspectives or projections. Maybe there's different ways of visualizing this thing that you're working on, this thing that you're designing. And to some extent, this has become a very mainstream idea. Like the picture that you see there is just some random thing grabbed off the internet. It's a typical layout of windows in the Eclipse Java development environment. We see text code in the middle, but on the panels on the left and the right, we see other organizations of the same algorithm. And so depending on what the programmer's momentary task or interest is, maybe they're going to use one of those, they're going to refer to one of those other windows as an assistance or something like this. So we were interested in exploring the possibilities for that as well. We decided to base the project on an existing live coding language, Tidal, which I think practically everyone here this morning has mentioned in one way or another, so yay, Tidal. And for this project, Tidal made a lot of sense for a variety of reasons. To begin with, this is a relatively short research project, 2 years, and Tidal is a very constrained domain. It's about cyclical patterns, right? Cyclical streams of events, not about a lot of other things that could be in a musical language. And so that constrained domain makes like a tractable target for trying to re-implement something with a different editing approach. It also has an active community, and in particular, the community where this research is coming from at Master around the cybernetic orchestra, a lot of people already knew Tidal. So there was this idea that practices that were already found around us might translate somehow into the new environment. But probably the design element that had the most influence on the project was and I think will have a lot of continuing influence going forward, was the idea of making something that would work entirely in the web browser. So using the web browser as a platform for this live coding environment. In the paper that you can read, we talk about some of the bullet points that I have there on the screen, that this enables us to provide potentially zero installation experiences to newcomers. There's security advantages in both directions. Web browsers are pretty good at stopping people from using them for bad things. They're not perfect, but they're pretty good. They have to be. And at the same time, they're pretty good at allowing things to happen when they need to happen, because web browsers are being used for so many things. So a lot of the technologies that are around us in everyday life are already accommodated to the kinds of communication that happens in web browsers. They're a natural venue for networked collaboration already. Masses of people are getting used to the idea of collaborating on web documents. They have adaptive user interfaces. When you design for the web, you know that you're going to be designing for different sizes and nature of device, and the browser environment supports you in that to some extent. And an argument that we didn't make in the paper that I would emphasize a little bit more now, I think, is that the browser environment it's really a natural, that's in quotes very deliberately, venue for artwork and performances that represent what is happening to us and our planet with computation. Artwork, in other words, that represents, critiques the digital network society. It's natural that would find expression in the browser, which is like the venue and site of many of those fundamental global experiences. And so I think in saying this, an argument I'm trying to push back against a little bit is the idea that by making things that are zero installation and perhaps sometimes simpler in the browser, that this is just kid stuff. I think kids are important, and I would like for this to be used by kids, but I think that there's another aspect of work in the browser that goes well beyond kid stuff, and I hope that in the future projects like Estuary will help us push more into that space. So since the browser context and developing for the browser influenced this project so much, I'm going to hand it over to someone who played a really crucial role in a lot of this development, Jamie Beverley.
Yeah, thanks, David. So the sort of workflow we're working with in developing Estuary, we're writing Haskell code using the Reflex functional reactive programming library, and Reflex DOM, which allows us to make and manipulate DOM elements in the browser. We're passing that through GHC.js, which is a compiler which will take our Haskell code and spit out sort of unintelligible JavaScript. So early in the project, we sort of started working on a model of titles. So that first sort of sliver you see there is how our model represents that title pattern below. And as title has sort of developed, our model that has sort of been trying to keep pace with it as well. But we've sort of come to recognize that it's there's a bit of a steep learning curve to working with this framework. So installation of Reflex is a little bit tricky, and generally learning Haskell is a bit of a steep learning curve, as I've learned. But once we sort of we've sort of reached a point in development where we're quite, I think, proficient with Reflex and Haskell, and since then development has been really great because we can appreciate some of the benefits that Haskell provides. Namely, Haskell being a strongly typed language, basically meaning that it's extra kind of picky about what functions can receive and what they must return. This allows for, this sort of creates more sort of compile time safety. So once we've compiled something, most of the time we can be pretty much sure that it'll work as we expect it to, so long as we haven't made some other sort of logical error. And our practice in developing Estuary has been to explicitly type all of our functions, which Haskell doesn't require you to do, but in our development process of doing this, we found that it helps us sort of reason about the code and think about our structures a little more. Another benefit of working in Haskell and compiling down to JavaScript is we can use all of titles functions by just importing like title.sound.context, and so we can run title functions without having to import an entire Haskell interpreter, which of course would be impossible for in the web, the browser. So this is sort of the overall architecture of Estuary. So it's hosted on a server that's run at McMaster University, but it can also be run locally. So everything you see sort of inside that box can be locally hosted. We have two different sound engines that we can target. One being through a Node.js program that communicates to the web browser over WebSockets. It sort of repackages messages from the browser and turns them into OSC messages. It forwards on to SuperDirt. So we're able to target SuperDirt for sort of performance critical situations where we can sort of appreciate the high efficiency of using SuperDirt, and also other advantages like writing our own SuperCollider synths and recording in SuperCollider, which can be a little bit difficult in the browser. And also there's this thing with the Web Audio API. If you have a synthesis patch running on one page and you switch over to another page, the audio processes on the previous page are no longer sort of prioritized and you'll get some glitches. But there's certainly still interest in our web-based sampling software, which is WebDirt. So we developed sort of a re-implementation of the original Dirt sampling software by McLean using the Web Audio API. And we expect, or we hope that WebDirt will have application beyond just Estuary. So there's some examples here of other ways we could use WebDirt to play individual sample, an array of messages, like a score, loading a score from the URL, or subscribing to a sort of title socket as we do in Estuary. So I'm going to speak a little bit more about the interface design now. The first sort of design, when we were originally building it, we were adopting sort of a block-based interface, as David mentioned. But we found that it quickly became quite cluttered. And to address the clutter and the sort of scaling of the interface to accommodate for collaborative editing, we chose to adopt more of a blank space as an interface design, where white space in this, or blank space, represents sort of a potential for interaction. So if you hover your mouse over a blank space, it'll sort of be greened out there, which sort of communicates that that there's, once you click on this, a context-sensitive menu pops down, which shows you all the sort of editing operations that you can do within this context. So by adopting this sort of interface, we not only sort of eliminate clutter, but also it's more sort of closely aligned with what title text structures kind of look like. And also there's sort of a theatrics to the pop-down window in that by hovering your mouse over and getting that little green window, you know there's something behind this, but you're not sure exactly what operations lie behind it. And then click on it, and then it reveals to you sort of the potential from which you can riff from. Another key design decision we made was to incorporate multiple levels of liveness. So in this concept, we're building off of and borrowing from Tanimoto and Church on understanding the different levels of liveness of an algorithm. So the two sort of liveness settings that we've incorporated are level 3 liveness, which means you can make live adjustments to an algorithm and evaluate them on the fly, but that requires you to make another sort of operation to evaluate, like command enter, like in SuperCollider, or other sort of keyboard shortcuts. And then L4, which is when the algorithm is sort of constantly live. Any changes you make to the structure are implemented immediately. So that little CP clap sample is live. So if I were to start changing the text inside that CP, it would be immediately propagated up. Whereas the bass drum sample there, its liveness box is unchecked, meaning that any changes that I make to that won't take effect until I hit evaluate. And there's also sort of a hierarchy or a structure here in that the liveness, the changes of this, because this is in a substructure of this larger structure, it'll only propagate out to its container. And then since this container's liveness is set to only propagate once you evaluate, it's sort of held at this level until that evaluation takes place. So now I'm going to hand it over to Luis to speak a little bit more about the collaborative design features.
Hola. Gracias. Como antecedente de Estuary está un ambiente de programación diseñado también por David Ogborn, que se llama Extramuros. Bueno, David Ogborn y colaboradores. Este ambiente de programación de Extramuros busca ser neutral en el uso del lenguaje de programación o en el uso del lenguaje, más bien, y por tanto no está afiliado a ningún lenguaje de programación. En Estuary se busca lo mismo. Entonces, en Estuary se pueden incorporar distintas definiciones de lenguajes de programación que se pueden utilizar independientemente o individualmente en cada uno de los editores. También algunas experiencias que ha generado Extramuros se han tratado de rescatar para Estuary, y esto es, bueno, al tener editores individuales, eso permite la realización de dinámicas y de juegos composicionales grupales, la posibilidad de manipular código y material sonoro de manera más rápida al no requerir instalación. De igual manera, como lo comentaba David y Jamie, no necesita instalación, todo es a través del browser, entonces eso genera una rápida posibilidad de manipular y ejecutar código. Bueno, y los editores individuales permiten la visualización, es decir, la agrupación de varios editores individuales en el browser permite que los miembros visualicen el código, o el código de todos se visualice por los miembros del ensamble, y esto permite que haya un aprendizaje de miembros o de participantes nuevos del ensamble a través de copiar y pegar, de copiar el código de otros miembros más experimentados y copiarlos en su editor individual y poderlo manipular. Bueno, y aquí hay que resaltar que que a diferencia de Extramuros, Estuary no es una herramienta de live coding, sino funciona más bien como una plataforma para gestionar múltiples ensambles e interfaces. Esta es una imagen de Estuary. Y aquí lo importante a resaltar son los distintos editores. Cada editor está destinado para un participante o un ejecutante dentro del ensamble. Y aquí se toma la filosofía, o una filosofía, digamos, o tenemos la filosofía de n número de editores para n número de performers. Nuevamente, esto nada más significa que cada performer tiene un editor individual. Y bueno, esto lo tomamos prestado del ambiente de programación Giver, creado por Charlie Roberts. Al tener un editor individual, o tener un editor individual para cada miembro, esto genera dos ventajas. Uno, simplificar el protocolo de edición, ya que cada editor individual se puede actualizar independientemente. Y dos, esto evita, o al tener, digamos, estos editores individuales, se delimita en dónde puede cada ejecutante escribir, y esto evita que haya tropiezos entre los distintos ejecutantes. Además de tener distintos editores con distintas definiciones, se toma en cuenta, o se tiene en cuenta esta idea de la comunicación no solo entre humano y computadora, sino entre humano y humano. Y esto se puede ver en la interfase de Estuary, en que tenemos, o en que tiene editores para notaciones secundarias. Por ejemplo, en la parte de hasta abajo de Estuary cuenta con, bueno, no se ve en la imagen, pero cuenta con un chat en el que los distintos miembros pueden comunicarse. Y arriba de los editores, digamos, primarios, existen editores para los nombres de los miembros del ensamble, y también pueden servir para colocar comentarios útiles. Un poco de trabajo a futuro que queremos realizar en la cuestión de notación secundaria es la posible incorporación de fotos de los usuarios, la utilización de distintas tipografías o de distintas etiquetas, por ejemplo, nuevamente para habilitar o para incrementar la comunicación entre los miembros del ensamble. Este es el modelo, esta imagen es el modelo de Estuary. Y bueno, esto lo que quiere decir es, existe un servidor que hostea o que contiene, digamos, distintas configuraciones, desde solistas, así como uno en un ensamble o varios ensambles. Y al mismo tiempo, cada ensamble o cada configuración puede tener distintas vistas. Y bueno, se puede reconfigurar o se puede reconfigurar las definiciones o los lenguajes de programación que se utilizan en cada uno de los editores. Se puede reconfigurar también el número de integrantes o de miembros que participan en el ensamble. Y bueno, ahí las definiciones quiere decir, bueno, son las definiciones de los distintos lenguajes de programación que se pueden incorporar. Y bueno, finalmente, el modelo de seguridad de Estuary está basado en contraseñas compartidas en vez de usuarios de crear usuarios independientes o individuales. Y esto lo que permite es incluir a más ejecutantes, a ejecutantes de manera mucho más rápida a un ensamble, debido a que solo requieren una contraseña. Y bueno, las contraseñas permiten crear ensambles y también permiten a los miembros del ensamble modificar y ejecutar el código. Y bueno, finalmente para escuchar el streaming o para accesar al audio y ver el código. No se necesitan contraseñas y esto permite que los administradores de los ensambles no tengan que compartir contraseñas con gente, digamos, desconocida o gente que está, a lo mejor está en otra locación, y esto evita posibles disrupciones y posibles interrupciones en el performance. Paso ahora la palabra nuevamente a David y que va a continuar con el trabajo futuro que tiene Estuary.
Gracias, Luis. So talking about future work, there are some kind of mundane things to do with performance. We'd like to make WebDirt and other parts work better in the browser. We have some ideas about that. We also have a nascent tutorial system that I think is kind of promising. If you've visited the Estuary software at all in our various social media promotions of it, you'll probably have found that there's nothing there. But there should be something there. We have an idea of what it would look like. We imagine that there would be a persistent live codable editor at the bottom of the screen, and at the top of the browser interface there'd be some text instructions, and what you could do is you could page through the instructions while that editor persists at the bottom. So there's a lot of stuff that could be developed there, including stuff in multiple languages. But I think that the most exciting direction that this can go in the near future is for Estuary to become a host and parasite for multiple and different languages, esoteric languages, as they're sometimes known as. I think there's just enormous potential for people to create not only art and music with live coding, but to create the languages with which they make art and music. So I'm going to pass it over in a second to our newest collaborator, Esteban Betancur, who has been involved with who has provided actually the first esoteric language to be incorporated into Estuary.
Bueno, entonces volviendo a lo de los lenguajes, este es una notación alternativa diseñada por mí, pero inspirada en chicos y nuevos programadores para patrones de Tidal. La representación que ven ahí, bueno, el lenguaje que tiene por nombre CQNs está inspirado en el Common Tidal, pues lo que hablé ahora, las expresiones básicas que están entre quotes cuando uno escribe Tidal, y un secuenciador de pasos tradicional. Entonces aquí lo que están viendo sería el sample al cual quiero acceder y la secuencia de activados y desactivados dentro del patrón. En este caso entonces es el sample BD y estaría activado, desactivado, activado. Eso tiene una equivalencia dentro del lenguaje, dentro de Tidal. En este caso solo se puede usar un sample por statement, o sea, cada una de las frases solo puede incluir un sample, pero también puede incluir transformaciones de los patrones. Entonces lo que ven ahí, en la segunda línea, por ejemplo, la segunda y la tercera incluye un sample, un Tidal pattern y en las transformaciones de ese patrón, que en ese caso sería break, fast, fast. Fast, como el lenguaje no incluye parámetros para las funciones, si quiero fast 2, 3, 4 aumentados, debo ser fast, 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 fast. Entonces en ese caso sería break, fast, fast, y el otro estaría en rev. O sea, está haciendo el sample CP con un solo trigger y está haciendo la función rev de Tidal al final. Así como este lenguaje que ya está implementado en Estuary en este momento, también diseñamos un segundo, David Ogborn, inspirado después y trabajó en el desarrollo de Mini Tidal. Que Mini Tidal es una versión, como dije ahora, que usa Common Tidal Expressions para que No todo el mundo usa todo Haskell para escribir sobre Tidal. Haskell permitiría implementar definiciones, nuevas funciones, ciclos do, pero no todas las personas que usan Tidal usan todo Haskell para eso. Por lo general, no sabemos cuánto, pero creemos que puede ser 80% de los que usen Tidal usan un common Tidal o un Tidal que solo usa este tipo de expresiones. Entonces es un Tidal donde se aceptan las transformaciones de patrones, los patrones, pero está simplificado. Simplificado no tiene, por ejemplo, al principio no hay que enviarlo a un buffer específico, de eso se encarga el parser. El parser es y Estuary en sí mismo son los que envían esto a uno de los buffers específicos. O sea, aquí no es necesario decir si va de 1 a de 2 a 3. Tampoco tiene los símbolos específicos de Tidal como el $, pero de resto es completo dentro del conjunto Common Tidal, que puede ser una nueva expresión de David, que entonces se resume a un lenguaje que también ya está implementado dentro de Estuary y que muestra justamente el potencial de Estuary para ser host o huésped de muchos lenguajes nuevos, lenguajes que pueden ser de fácil implementación. Por ejemplo, el parser de estos dos lenguajes, quizás el de Sequence tiene como 30 líneas, 35 líneas. El de Mini Tidal es más grande, pero tampoco es un parser infinito, son quizás 80 líneas, creo que lo que tiene ese parser. Pues con eso quiero decir, para terminar, que no es difícil implementarlos. Además se pueden implementar como librerías paralelas. Es decir, no hay que hacer todo el requerimiento de instalación del servidor, sino que están aparte como módulos externos cada uno de estos parsers. En este caso tenemos 2 implementados, pero se abre la posibilidad para implementar muchos nuevos lenguajes.
All right, we're almost done. I want to just quickly mention some follow-up items for this, and then hopefully have a minute or two to show some things to you. So we do have a workshop about Estuary this Wednesday, 6 to 8 p.m. at the Comité de Asuntos Intangibles. And we'll mostly devote that workshop to an even split, I think, of jam sessions, collective jam sessions with the software, and we hope to create a new on-the-spot esoteric language that, if it doesn't suck, we will use in Friday's performance. We can call it Morelia or something like that. So we do have a performance this Friday in the Alvarez. And then I just wanted to call your attention, we have a new laboratory at McMaster where we're doing this research, the Networked Imagination Laboratory. It is a space entirely devoted to live coding and network music, and can host guest artists, graduate students, all kinds of crazy things that you can get in touch with me about. And one of the ways to get into the lab and to join the community would be to do graduate degrees at McMaster. We do have an MA and a PhD. There's lots of funding possibilities for both of them, and again, the chance to work in that new lab. So if that interests you or interests anyone you know, please feel free to put them in touch with me, because I think there's a resource here for the community. So I'm going to demonstrate a little bit now. So I have the software loaded up in a browser. I could have loaded this from a USB stick. The server is only required if you're going to do some online collaboration. In the upper right here, I can choose which sampling engine I want to use. The default is WebDirt, because most users are going to be connecting to this over the web. But I can switch that off and send things to SuperDirt instead if I want all those Super Collider advantages. Here is the empty section of tutorials. I can go into a solo mode, and in the solo mode I'm presented with a default view or collection of editors that point to live coding definitions that includes a bunch of different types. On the upper left here, we have the structure editor, if the audio is on. Yeah? So we kind of relaxed a little bit from our click-only thing, as you can see here, because there's just so damn many samples in dirt that it's hard to put them all in menus and things like that. So we went back to letting people type the sample names. But as I add, say, a transformation to this, I'm back in the click-only mode with a little bit of typing. Generally delete or reverse things by clicking on them again. Here's mini title down here. Sounds familiar. We haven't got the liveness controls that we have in the other one worked out quite yet. Should add that soon, because right now when you type something that doesn't, it's continuously evaluating. When you type something that doesn't make any sense, things stop. But all of this is being evaluated in the browser. Maybe that wasn't a very good choice. There we go. So it starts to work right away when you load it in your browser, which I think is really, from the beginning, has been the main purpose of the research project. Here's a mini language, Esteban's sequence. So a fancy collaborative environment for this. I just want to sort of briefly show you the different view systems. So someone was here already. So there's a terminal at the bottom where we can chat, but if you put an exclamation point at the beginning, there's lots of hidden instructions that reconfigure the view, as well as a preset system. So if I type preset view, ICLC 2017, I'll reconfigure that ensemble space, and I get a bunch of different configuration of editors pointing to different definitions. I would say that we didn't strongly explore the projectional aspect in the course of the research project, but I think it's come about in a way different than we expected, which is that when you have these ensembles and you have all these editors, each of which points to a definition in the live coding ensemble, you can have different configurations of views, and they're all pointing at the same ensemble. So we can do things like have people seeing what everyone is doing on the same screen, but we can make a different view of the same ensemble, connect it with a different browser, and connect a second projector to that, for example, to distribute things around the room. And there are probably other applications of this as well. So I think that's all we have to say. We've gone on a little bit long, and I imagine the organizers want us to shut up, but maybe there's time for a question or two, and thank you for listening.
for example, like using npm or to be able to use just like the WebDirt aspect or just the title compiled?
So WebDirt is a separate repository at GitHub, and so it's pretty easy to drop into other things, I think. The rest of Estuary is all built using this Reflex platform. So to use a lot of it, you have to commit to that platform and that build system, which is where there's a bit of a steep investment. But I would say one exception to this, and this might be an interesting thing that happens, I don't know, between and around the title community, is these mini languages that we're talking about. The way that we're making them work is by writing parsers that return title types or things that we can convert into title types. And right now all of those modules are in this project, but they could as well be elsewhere or somewhere separate. So, I guess I'm overcomplicating the answer. I think the short answer is there's lots of reusable stuff here for sure. And even if it's not currently in the most reusable form, people can just cut it off and rename it, and then it will be reusable. Yeah.
Thanks for the presentation. It's pretty amazing. In terms of its projectional editor, is there literally one base abstract syntax tree for the whole for every piece of running code, or are they still kind of separate for each mini editor?
Yeah, so there is one model of the syntax tree, but it is a ugly, hacked-together model with parts that are there for different reasons. And then when it's a matter of network collaboration, certainly it's not. It's just parts of the tree that are being transmitted back and forth. So I'm not sure if I'm answering your question.
Yeah. The whole question I was going to ask you, how easy would it be to offer a new projection?
The hard part is just getting used to this Reflex environment in the browser. Like the graphical user interface part of it. This comes with some tedious stuff. But I think it's quite. I think it's still manageable, and it would be great if this project did become more of a community of people added interfaces to it, because I do think that what we do have with here is a kind of relatively neutral meeting point, where if someone does undertake the task of making a new projection, we can incorporate it into this with basically no consequences for the rest of it. It doesn't become like a big management task. It should be maintainable.
Yeah.
So that's cool.
Yeah. So if I wanted to make like so I've seen some projection editors where they have like, LaTeX mathematician and all kinds of stuff all together.
Yeah.
So would it be possible for your system to make like a purely visual projection or something like that?
Yeah, we meant to do that, and we haven't done it yet, but we totally should. We've talked about this in the chat sessions that you always have around these projects. Like the part in the upper right where you see SuperDirt and WebDirt, we imagine that growing into like maybe you have to click and you get a control panel, and there's lots of different rendering engines, and basically the rendering engines get to choose themselves what they want to harvest out of the syntax tree. So you might have some visual rendering engines, and they go looking through and they're like, oh, that one's for me, I'm going to render that, and they do it, But if you don't want that rendering engine, you want another one, you turn it off, you turn the other one on. I think at the end of the day, the important thing is that it all just has to work immediately upon loading it. And if it does that, then I think it will be a great part of the project. Yeah?
What motivated the decision to
Well, really it was because title is written in Haskell, so it let us reuse and build around the kernel of that code. And it's also really fun. And JavaScript is not really fun. And we get like bragging points for saying that we did it. Well, we gave some reasons at the talk too. I'm trying to think of the other real reasons why we did it. Yeah. I mean, I do it again. We've done other projects. I have a project working on with Eldad, who's also on this project in the back of it. It's an ear training environment that is web-based. And we're building that using Reflex as well for many of the same advantages.
Oh, yeah.
You mentioned some of the difficulties in web audio. I mean, how far along do you think it is towards being a stable performance environment? And do you think, I mean, basically, what's the time for that? That's a tough question.
Yeah. And when do I think the revolution will break out? I don't know. But from the standpoint of this project, our ties to the web audio API are relatively thin. So we have kind of one module somewhere where our stuff gets translated into the terms of the web audio API. So whatever happens with that, if it is, for example, that it becomes really possible to write nice synthesis stuff in WebAssembly, it may already be possible, I'm not sure. There may be people in this room who are already doing that. Then there'll be a job for us to kind of rewrite WebDir in WebAssembly and hopefully gain some improvements.
So it's still got a bit maybe. But
yeah,
it could still be useful. I mean, there's people who are doing, recording of live coding, dumping that into Git and then playing it back. So it could be an interesting, live rehearsal, collaborative composition platform that then gets played back more stable, I guess.
Mm-hmm. Yeah.
It's interesting.
All right. Thank you, everyone.
Hola, un pequeño anuncio ahora. Vamos a tener 15 minutos para comenzar el workshop acá de cine vivo con Esteban Betancur. Los interesados, pregúntenle a Tito.